All right, well, welcome to EUC1797. This is Troubleshooting VMware ThinApp applications. My name is Dean Flaming. I am one of VMware's Horizon ThinApp specialists, end-user computing specialists. I cover pretty much all of North and South America with another coworker of mine. And this coworker here is Peter Bjork. He's from Sweden. Peter, say hi.
Hurdy, burdy, moody.
No, Peter. You gotta do it in English, man.
I can't do English. It must be Swinglish.
Okay, Swinglish.
Okay, I'll do it in Swinglish. So,
okay.
Hi everyone. My name is Peter Bjork, or Björk, as it's supposed to be pronounced. I work as the ThinApp and Horizon specialist for the EMEA region.
Excellent, great. So let's get started. So yeah, and first thing we have to show is our disclaimers, of course, and. Of course, there we go. So, so the reality is on applications, there really is no silver bullet with applications. Peter, I know you always like to go into this. There's just tons and tons of variables. We live in a world where there's a whole lot of variables. Myself, I like to say that, not just the application is a variable, but the environment you're launching it in is a variable. And of course, my favorite is every launch of the application is also a variable. So there's just all sorts of things we have to accommodate, and it's really hard to do so. So these are things you really need to keep in mind. Is there anything you wanted to add in Swinglish?
Nope, that's good. Not yet.
Not yet. So one of the things we like to talk about when we go into troubleshooting of an application, or when we just go into troubleshooting in general, there is a scientific methodology for troubleshooting. You always want to observe, ask some questions, do some research, data collection, and go through the whole process of constructing your hypothesis and figuring out, is this really going to work? And then let's test it out, develop a test procedure for that hypothesis, then go through the analyzation of it, experiment with the results, collect that data, always take notes on that, and then determine, is that true or false? Did I get a good result or a bad result? Because, well, I shouldn't say a bad result, because there is no bad results, it's more data. So then you take that, what is it, who is it? I'm trying to think of off the top of my head. The light bulb inventor, Edison. Thomas Edison said, I didn't fail. I just had 10,000 solutions and issues that didn't, or ideas that didn't work out. So test those hypotheses, then come back and say, think through it again and develop another test with that new data. And of course, if it does work, then always record your results, report your results, and move on. So we always want to have a well-defined testing procedure, because we don't want the Sith Lord coming back at us and saying he doesn't like our testing. So a well-defined test process is always key.
So the test procedure in order that we use, both Dean and I, and this is a test procedure targeting to lower the amount of variables that you are facing. Trying to digest the amount of data that we get, and so we can focus into an area of interest. So we have this 4-step procedure, and the first one, for lack of better wording, we call the dirty test. The dirty test means that on your capturing machine, you have the application you just captured with the help of setup capture still locally installed. You run your package. Most of the time, I would say close to 99% of the times, the application will actually launch in this configuration. If the application failed to run, it's probably due to one of two things. It could either be our runtime have an issue executing this application. If that's the fact, it's probably not much you can do about it. You probably need to file a support ticket, and our engineers has to have a look at it. The second alternative is there is something wrong with your entry point. The entry point may have a command line equal parameter, which is using illegal characters or something else. Another very common reason for failure during this test is the lack of a working directory. You have the package.ini setting called working directory equal. If you fail to specify this working directory, the current directory or working directory will be wherever the package is located. And if the package is located on a network share, for example, a UNC path is not a valid working directory, so you will be defaulting to see Windows. So if the application is referring to components relative to its working directory, of course it will fail if the working directory is somewhere else. The second test we call the wash test.
Third.
No, the second.
Oh, I'm counting wrong. Wow. It's the
You're way ahead of me.
Sorry.
The wash test is still on the same virtual machine where you have the application locally installed, but now you go in to add or remove program and uninstall each component. If you have captured multiple components, you uninstall one at a time and test your package between each uninstallation. So let's say you have captured an application requiring Java. So you have one Java installation and one installer for the actual application. Uninstall Java, the package may still run happily.
I'm sorry, uninstall what?
Java. Java.
Oh, Java. Java.
Java.
Coffee.
Coffee. The Java runtime engine. You uninstall that, test the package. If the package functions, you uninstall the application itself. If the application now fails to launch, it's bound to be something to the the regards of the application. You could discard Java, JRE. Yeah. Secondly, when this test, so for each test must be successful. There is absolutely no point in continue testing or jump ahead to next test procedure if you fail at a certain point. But let's say the wash test is successful. Now you start the clean test. Clean test means that you revert your capturing environment into a vanilla state. So probably you revert your snapshot of your virtual machine. You must not introduce any new variables at this point. It must be an identical virtual machine operating system as the one you started your capturing process on. And when this is, so if the application is successful at running the clean test, then you know ThinApp has absolutely no issues virtualizing this application. Your confidence level in ThinApp's capability is very high, and everything that may fail during the next test phase, the production test phase, is bound to be environmental. It has nothing to do with ThinApp's capability of actually packaging this application. The fix may be something that you could add or implement into your project, your package, but the root cause of it has nothing to do with ThinApp. Something you want to add to that? Or
no.
Crystal clear?
Yes.
So this is just simply putting the scientific method into practice when it comes to ThinApp. So you covered most of this already, so I'll just skip through it. What is very important, between each step, you may encounter new data, new information. Make sure you document all your findings, because if the business justification is there, you may be allowed to spend several days, several weeks on troubleshooting one single application. So if you encounter something on Monday, but you pursue something else, you definitely have forgotten this on Thursday or Tuesday. So then it's good to have a list of just small notes of things that you come across.
Yeah, and a lot of times I'll just take screen snapshots too.
That's a great
Another good
idea.
thing at this point also is for documenting is use the technology that's there that you have. Use the VMware snapshots. Use whether it's in Workstation or Fusion or vSphere. Use the snapshots, and then you can have a point to restore back to them, and you also have those notes in there as well.
So The 4 test procedures was targeting lowering the amount of variables that we are faced with. Then we need a test procedure to verify or test our hypothesis. And I would argue that running the virtual environment and applying changes to a running environment is by far the most effective method to do that, or method to do that.
So when you say running the virtual environment, are you talking about enabling the virtual command prompt and the virtual registry entry points that are there for troubleshooting?
Exactly. So most of you, you know that we use something we call entry points to launch something within the virtualized environment of our package. We could add entry points to the locally installed cmd.exe or regedit. And when they are launched as entry points within the virtualized environment, they will see the whole environment as known to the application. So now you can actually put yourself in the application's point of view. So you see the merge that happens with the native environment together with the virtualized environment. So the benefits of doing this is that it's very, very fast to apply changes. So if you need to copy something, and we have a demo of this later, so we can copy something into the virtual environment immediately affecting the execution of our application. We modify everything in the sandbox, so it's contained, the modifications we are doing. The benefit is also instant gratification. You will know immediately if you have solved the issue or not, instead of applying the changes into your project folder and recompile your whole project folder. It's okay if you are virtualizing Mozilla Firefox, for example. It takes less than a minute to compile. But if you have created an 8 gig large package, it may take 1 hour to compile. So then you need to make sure that each single compile operation counts. So you would like to minimize the amount of build operations that you do.
Yeah, so for something like Office, you don't want to recompile that very often.
No, Office takes on my machine approximately 30 minutes to compile, so it's just a lot of waste of time. Another benefit, it's very easy to revert. So let's say I tried a couple of registry settings, I tried to copy a couple of DLLs and registering them, but it didn't solve my issue. Shut down the application, delete the sandbox, and start all over again. And when you finally figure out the issue, so you have the fix within your sandbox, we have a tool called SB-merge, stands for sandbox merge, that will take the content of the sandbox and merge it into your existing project folder. Not all changes can be applied to your running environment. Changing isolation modes could, in theory, be changed with the help of VB scripts, but in practice, you wouldn't do that. So in order for you to change isolation modes, unfortunately, you have to rebuild. But just make sure that each rebuild counts, so you don't waste a lot of time doing a lot of rebuilds. And we must make sure that the default isolation mode is write copy, because you don't know up front where you will apply changes. Let's say you need a temp folder in the root of C drive. If you are using merged as the isolation mode, and you create this temp folder, it will be created on your native machine instead of being sandboxed, which means the SB merge will not be able to merge the complete set of fixes into your existing project.
So by default, the isolation level that is selected when I go through the wizard to capture an application is merged. So in order for this testing, hypothesis testing and configurations, I should change it to write copy, just so that I can go make those instant changes on the fly.
Yeah, that's correct. So that brings us to the topic of tools used for troubleshooting. I would say troubleshooting tools is probably the wrong word for it. I have yet to see an application displaying a dialog box where it tells me what's wrong and how to fix it. These are data collection tools. You will collect data, and then you will filter that data with your experience and knowledge in the product, and hopefully figure out what is wrong, or at least create a hypothesis that you later will test if it's true. So whatever tool you use today as an MSI packager, you should use when you troubleshoot ThinApp. ThinApp is just another packaging technology. So many people are using Process Monitor today, Process Explorer. They originated from sysinternals, but they are now a part of Microsoft.
Some of you may remember the old File Explorer and Regmon, FileMon and Regmon. That's the Process Monitor is the continuation of those tools.
Yeah. And we bring our own tool to the table, the ThinApp Log Monitor, which, in all honesty, it's a beast. It produces massive amount of data. The whole purpose with Log Monitor is to help our engineers, our developers, to debug our runtime. So everything that happens within the virtualized environment is tracked. And that's the problem. Yeah. You are overwhelmed with the information.
Yeah, they did a great job of laying out the text, the log files, but yeah, there's just a ton of data in there.
Yeah. So we will discuss a little bit how to filter through the Log Monitor. But in all honesty, I turn to Log Monitor as my last resort. I normally use other tools as listed here when I conduct troubleshooting. Don't forget to investigate the event viewer. ThinApp packages do track events in the Windows event viewer or event logger, so you can look at it with the event viewer. Dependency Walker is another tool. I find that either you use Dependency Walker or you more or less never heard about it. Dependency Walker will show you dependencies of a certain process. When you use Dependency Walker, do not point to your package. Because if you point to your package, it's our runtime's dependency that you will track. So
that's a good point.
Yeah, you need to run Dependency Walker either within the virtualized environment.
On the dirty test section of the process that we were talking about earlier.
On a clean, you can run it here and there, I would say, because it will show you where the dependencies are missing. So where the DLL, which DLL is not there, for example. Especially important when you migrate from Windows XP to Windows 7. Quite often, you have certain DLLs available on Windows XP, but when you move the package to Windows 7, those DLLs are either newer versions or they are simply not there. So then Dependency Walker will tell you which DLLs the process is missing. And error messages. You get a dialog box stating, I cannot find this file. Please do not simply click OK and forget about it.
Take a screenshot.
Take a screenshot. Investigate why that file is missing.
And the really nice thing is, and I know we're probably going to mention it again later, is those error messages, you can search through the ThinApp Log Monitor for those error messages verbatim. So write those down, and then when you search through log monitors, the Log Monitor logs, you can search for that exact text and then look above it in the timeline and see what actually is causing that error.
True. Then I would encourage you to get to know your application. Getting to know your application, you cannot simply buy them a beer or take them out for a date or something. So we need to figure out a different way of,
is that how you do it in Sweden?
Yeah, sure.
Okay.
That's how we get to know people, at least. So my suggestion, and what I always do, is I launch the application, immediately shut down the application. Do not touch anything. Investigate the sandbox. This will tell me quite a lot about the application, at least what it modifies on its first initial launch. If this creates a massive sandbox, that tells me that something is probably a little fishy with this package. I like my packages small. The sandbox should be as small as possible. So investigate why it creates this massive sandbox.
What do you normally see in there?
temp files. Temp files is definitely...
Database files.
Database files are always modified, so therefore they end up in the sandbox. Could be pretty much anything. Not located within the sandbox, but connected to this topic is the fonts. If setup capture sees that new fonts is being registered during the capturing process, we actually support virtualization of those fonts. But in order for us to be able to activate the fonts, we need to copy the fonts out from the package and put them on the physical disk before we can register the fonts. This could be a time-consuming effort, especially if you have 100 meg of fonts. The fonts gets copied by default to the local profile of the user, so that's where you'll find the fonts. I would recommend to not virtualize the fonts. Take them out from the project. Register them on your golden image instead, or your base image, because that's what you would have done with a natively installed application. So I don't really see a reason for not doing it with a virtualized application.
Yeah, and that's a really good point, because when you're installing these applications natively, a lot of that startup time of the application is really just masked by the startup of Windows, the login of the user, those fonts being already registered. All of that's all taken care of. So when you virtualize the application and run it in a separate sandbox or in a virtual bubble all by itself on a clean system or on a production system, it's got to go take care of all those steps in the process, startup services, in which I'm probably jumping the gun there a little bit, but registering of fonts, those kind of things. So
yeah. If you have a package you suspect have a lot of fonts and you would like to compare the differences in launch time, there is a more or less undocumented feature, a fairly new parameter, or it's actually an environment variable that you specify on your desktop where you test run your package, and it's called no_fonts. If you just add that as an environment variable to your system, no value is needed, then it will discard loading the fonts. So that's a funny test to do. So activate the environment variable, launch the package, and you will see quite a big difference in launch time if you have virtualized the fonts. And then to get to know your application a little better, I launch the application and then I use the application to the fullest of my potential. So I don't know how to use most applications out there, but let's say if it's a word processor, at least I can create a document. I can save the document, I can print the document, I can open the help file, open settings file, play around with the application as much as you can, shut it down, and now investigate the sandbox. What is the sandbox content? And ask yourself, what I find in this sandbox, should it really be there or not? So, the log monitor, we just had to talk a little bit on this one. First of all, never ever use Notepad to open trace files. It will not work. And most of the time, your log traces are 1-2 gig of clear text. So you need a decent text editor. TextPad is my favorite.
EditPad Lite, Notepad++,
yeah.
Those are some other ones. Yeah.
All of those works. On Mac OS, I use Text Wrangler, which I find a very good tool. When you open the trace file, search for potential errors. It will be a section at the end of the log file. Here we list all potential errors, like the name of the section says. You will always find potential errors. The application perhaps investigates if the registry key is available or not. If it's not, it will raise an error flag, but it will happily continue executing.
Yeah, so remember that there's a lot of applications, even when the application's running normally, you're still going to have artifacts. You're still going to have potential errors that show up. And it's just a natural occurrence of the application because it's searching through, like you said, the registry, and it's just looking for environment things to tell the application how to work properly. Oh, I'm in this configuration of an environment. I'm on this type of an operating system. I'm logged in as this type of a user. Whatever it's looking for a number of things, and if it doesn't find something, that's where ThinApp will register it as a potential error, even though it really isn't an error. It's just something that's potentially not there that it was looking for.
Yeah. Just make note that we will track child processes with different log files. So you may end up with 10 different log files being produced. And the error may occur in a child process instead of the main process. So just make sure that you investigate all of the log files. If you launch the package from a network share, we have a function of relaunching ourselves. This is mainly due to antivirus software, so they will not lock the whole package and try to scan the whole package when we stream over network. So this will produce 2 logs always. Make sure that you look in the active one. But it's pretty obvious. One is 2 gig, the other is 0K. So, if you get, we mentioned this before, but if you get an error message, that error message most of the time is listed in clear text within your log file. So search for the location where the message box is created, and whatever forced the error message happens before the error message, of course. So you can discard the rest of the log file. And this is very important. Kill the application immediately when the error occurs. So if you get an error message and you click OK, File, Exit, you will continue to produce a log. So now your error is somewhere in the middle of the log instead of at the end of the log file. If the error state occurs somewhat in the execution, so after a while when you have launched the application and opened a special
reports or something along those lines. Yeah.
Then we have a function in Log Monitor to suspend logging. So then you start Log Monitor, click Suspend, and then you navigate to this point where the error state will show itself. Unsuspend Log Monitor, force the error to occur. Everything so that we minimize the amount of data that we collect.
Yeah, and you can actually start Log Monitor first, and then suspend, then start your ThinApp, or you can have your ThinApp running and start Log Monitor. It'll work either way.
And then just a note that you could actually, while the execution is happening, you can generate text versions of the trace while you are executing the application. So, should we have a look at some troubleshooting examples? We have 2 of those today. And this one is the pictures is taken from this great blog post here from one of our V-experts. And I liked it because it explains the behavior of MSI in a very, very easy to digest format. So I asked the guy if I was allowed to use this as material for this presentation. So I will walk you through a very common issue that you will find with ThinApp packages, and that is MSI self-repairs. Why is that so common? You capture on a clean machine most of the time, and then you move the package into a production environment where you have hundreds of more applications available. This application will now try to interact or integrate to some of the applications that are all of a sudden available. And this may force a MSI self-repair. So it's definitely not uncommon that you see self-repairs. On the other hand, most of the time it's quite easy to fix. So I want to walk you through one method of fixing this. When you have MSI self-repair issues, start by looking at the event viewer. you will find an event similar to this, explaining which product, which feature, and which component that failed to load. And in this case, it actually tells us in clear text what the issue is. In this case, the issue is missing a registry key.
But, that's nice of them.
Sorry?
That was nice of them.
Yeah, it's nice of them, but it's not always that easy, so I will use this and we will pretend that we don't know that it's actually missing this particular registry key. So, just some MSI basics. So probably most of you already know this, but an MSI contains one or more products, most of the time only one product, which is built up with the help of features, one or more features. So when you choose a custom installation and choose different options, it is different features that you choose to install. And the feature is built from one or more components. So when you click on a certain feature, it means you will actually install a couple of components. The creator of the MSI file can decide that a certain component is so important that we need to add a key path to it. A key path is a file, folder, registry key. If this key path is missing, MSI should self-repair itself, or MSI installer, Windows installer should try to repair this installation. So it's simply the creator of the MSI package that decide what is considered important or not. So in this case, it tells you that the product, GUID, the feature web client in this case, uses the component, another GUID, and the key path is the registry key in this case. You will find all features, components, products being installed, most of the time at least, in this registry, the part of the registry. So this is where you will have to find for your component, search for your component, and find the key path. Here I navigated to the component, and it specifies the product, but here the most important thing is this is the key path. So let's say I run, in this case, I launch my ThinReg within the virtualized environment. The solution to this MSI self-repair is to simply delete the key path. I could, of course, create the key path. I could create the registry entry, or I could copy, if the key path was a missing file, I could simply have copied the file as well. So if you should delete the key path or actually add the key path into the virtual environment depends on the situation and the application. But now it starts to get a little more interesting. Unfortunately, the text is too small, so you will probably not be able to see it, especially not at the end of the room. But the event tells me that it's the component 3D9E55 and so forth. The registry editor here points to E955E. So they are not the same. So how do we translate the GUID we see in the event and to the actual record found in the registry? And this is the conversion table. How many knew about this? 3 guys. So it's unfortunately, this is the way it is. It's just something we have to live with. The reason, your guess is as good as mine. I hope it's because Microsoft don't want people messing around with the registry, so they are trying to make it a little harder for people to find things. But what you do, you take the first part of the GUID and read it from right to left, second, right to left, third, right to left, and then now it starts to be really interesting. You switch each two numbers.
Swap the two.
Swap them, and then read them from, what is this, left to right. It's starting, this is way too complicated to try to explain in Swinglish. But you see the arrows and the pointing. It's simply, this is the simple matter of how it is. So you just have to learn it.
This is the broken down, this is the quick version of what's on that blog posting we have listed before. And you'll get a copy of these slides as well, but it is gone through in serious detail on that blog posting. Yeah, so the blog post I reference here go through the same example. On our ThinApp blog, you will receive the URL at the end of the presentation. I go through a project 2003 captured on XP32, providing or giving me an MSI error running on a 64-bit Windows 7. So it's the same idea. Mm-hmm. So we can use Log Monitor to find MSI-related issues as well. Start by searching for msi.dll, because that's always a DLL being called when we start the self-repair. You should search for format message. Those are of interest. And where you see the MSI DLL, search upwards for accessing the registry or accessing files. Format message is the pop-up for your text error, right?
Yes, it should be, yeah. The return value of the reg query get file attributes APIs is what's of interest. And you're not supposed to learn this, but you will get the presentation, so I just wanted to put it in the presentation for your reference, so for later you can download the presentation.
There'll be a test later in Swinglish.
No, in Swedish, actually.
Oh, okay.
So, key takeaways when it comes to MSI self-repairs. If you are launching something natively installed within the virtualized environment, perhaps your virtualized application calls and loads something that is locally installed already. If an MSI appears, it's probably due to you are hiding too much of the physical environment. So the native application is used to be able to see this part, this environment, and now it can only see a subset of it. Therefore, it starts to self-repair. The other way around, if it's the virtualized application that produces the MSI self-repair, then you probably are showing the virtualized application too much. It sees these components and wants to interact with it. Try to fully isolate the virtualized application so it cannot see these components or features. And of course, you should use regedit running within your virtualized environment for effective troubleshooting. And then we have another case study. This is from another era. This was, I used to work at ThinStall, and back then we had, so ThinStall was the old name for ThinApp before the VMware acquired ThinStall. Back then we were facing a migration, many migration projects from Windows 2000 to Windows XP. Now we are facing similar migration issues, Windows XP to Windows 7. So the problems are more or less identical. But this case is from a Windows 2000 migration project to Windows XP. The application requires Windows 2000, Internet Explorer 5.5, QuickTime from the beginning of mankind, and a CD-ROM, a physical CD-ROM. So you could imagine this CD-ROM was either broken or lost on a weekly basis. So the objectives...
And it was for an educational facility.
Yes, sorry. It's an educational software. Yeah. So you can imagine a line of students requesting CD-ROMs every Monday. So get rid of the CD-ROM was easy. We can virtualize not device drivers, we can virtualize drives. So I simply virtualized a fake CD-ROM, put all the content of the CD in the folder, and so that was fine. And the next objective was to make this application run on Windows XP. And Windows XP contains Internet Explorer 6, as you remember, and some other components that, or it lacks a couple of components that is available on Windows 2000. So the first video here is showing a clean test. So I run the application. Can we not?
I'm looking for the...
There
we
go.
go. Yeah. There's the mouse.
So this is a execution on a clean machine, clean Windows 2000. So this is my project folder, my bin folder, and then I execute the application. Unfortunately, you do not see the mouse movements here, but hopefully you understand that I'm clicking here. And it presents an embedded QuickTime movie, and now the students can read about the experiment, and they can see when it explodes or fire or smoke starts to appear. So, dirty test, clean test, wash test, all green. So my confidence in ThinApp is very high. I know ThinApp has absolutely no problem virtualizing this application. I cannot do the dirty or wash test on a Windows XP because I simply cannot install the application on XP. So I move my package now to my XP, so it's more of a production slash modified clean test.
There we go.
Also a clean XP because I just want to add the minimum amount of variables. I don't want to have an XP with Office and all different applications installed. I want it to be as clean as possible because we added a couple of million variables simply by changing to a new operating system. And navigating to the same page, as you can see, the QuickTime is not loading. But do not focus purely on what is not functional. Now we can realize that IE55 isolation is working because I can see the text. The text is rendered using IE55. So isolation of Internet Explorer 5.5, we have IE6 locally. That isolation works. So that's a good thing. I don't have to care about that. The GUI of the actual application seems fine. So that's working as well. So the only thing not working is QuickTime. So my next step is so the clean production test failed, and then since I'm so highly intelligent, I came up with this conclusion. Differences.
Rockstar.
Difference between 2000 and XP. That's the reason this application fails. We need to do some data research, data collection. So eventually, after a while, I turned to Log Monitor. So I will not pretend I fixed this in 10 minutes. I surely didn't. It took me probably 3-4 hours using other tools. But eventually, I turned to Log Monitor. And when I use Log Monitor and I have an environment where my package is successfully running, and another environment where it fails, I tend to produce logs from both of them and then compare the two logs. Not line by line, because that will be impossible, but I search through them. So I started with the Windows 2000 trace and searched for QuickTime. I found 3,000–4,000 entries. I turned to XP log, searched for QuickTime. I found 3 entries. I went back to my Windows 2000 log, and right in the beginning where QuickTime was referenced for the first time, I saw this QuickTime.ocx. And that tickled my interest, so I went back to my XP trace and searched for plugin.ocx because I knew it looked like QuickTime was used as a plugin to my IE55. So I searched the XP trace and found 0 entrances of plugin.ocx. So I Googled plugin.ocx and found out that plugin.ocx had a major security hole in it. So the solution from the vendor was to, with a service pack and with Windows XP, simply delete the file, and the issue was gone. So
the issue was gone for the security hole, but not for you.
No, it gave me an issue instead. So that gives me an interesting theory. What happens if I introduce plugin.ocx to my Windows XP machine? Not on the machine itself, but within the virtualized environment. So then let's go ahead and test this theory. And the most effective matter or way of doing this is to apply the change into the running environment. So what I have done prior to start the recording on this is to take plugin.ocx from Windows 2000, put it in the root of C drive. That's not the location it's supposed to be in, but I launch my CMD entry point within the virtualized environment and copy the file into the correct location. This will modify my sandbox. It will capture this change and store it in the sandbox. And then, more importantly, I can register the plugin.ocx as well. And now I'm looking for this instant gratification. So I launch the application, and voila, it works. So now my fix, as you will see, I will navigate to the sandbox in a second. My sandbox contains my fix. So there is plugin.ocx copied to system, which means system32 folder. And the registry has been modified and updated with the registration information as well. So now I have a clean test or a production test that is green. Now I need to create a working version of my project. And then I turn to SB merge, sandbox merge. Sandbox merge must be initiated or launched outside the virtualized environment. So you should not use the cmd.exe entry point. Here I'm running the native cmd.exe. Place yourself in the project folder when you run SB merge, because then SB merge will find the project folder and its active sandbox automatically. The parameter apply means that merge the content of my sandbox into my project. You could run print as the parameter, and then we will simply see an output of all the differences. Now SB merge has successfully updated my project folder. So here you can see that plugin.ocx is now put into the project folder. Of course, I could, and then I have to compile my project. And now I'll get my production version of this package. Of course, I could have copied plugin.ocx. But I didn't know up front that this was the fix. So instead of waiting for the compile operation, I'm not even recording. I didn't record the whole build time. Now I could test this first by copying the file using the CMD entry point, which is much more efficient. And more importantly, the registration of the plugin would have been much harder to apply manually into the project folder. So let's wrap this up and look at your day-to-day capturing process. I do not recommend you to run through all 4 steps, test procedures for each one of your packages, because most of your packages will work out of the box. So this process I find useful, and it supports the test process as well, which is important. So you start by capturing your application, and then you perform the dirty test. You launch the application, shut down the application. You investigate the sandbox. What's the content of the sandbox? Remember, I wanted to get to know the application a little bit. Try to delete the sandbox. If you fail to delete the sandbox, it means there is a child process keeping the sandbox locked. So your virtual environment never shuts down.
Like Office normally has CTFmon that's running in the background, or
yeah.
a couple other things too. So
MDM.exe, auto updates. You definitely should disable auto update in all applications that you're capturing, but that's another thing that could keep your sandbox locked and open. So, if all of above is successful, snapshot the virtual machine. This is not a ThinApp snapshotting. We have way too many snapshots going on. The virtual machine you're using for capturing, create a snapshot. And then you can move on to the production test. If the production test fails, now you have your snapshot to go back to, return to, and do a wash test, and then clean test, and hopefully you will be able to minimizing the variable and figure out what the root cause is.
The nice thing here is if you also, with taking a snapshot, if you need to add something to it later on, you're at the point now where you can add something and then continue on too.
So how are we doing on time?
We have about 10 minutes left.
10 minutes left, okay. So here's a couple of good to have links. Of course, our blog, it's Dean and I and some other guys producing technical posts. I think since 2008, 2 marketing posts have sneaked in there.
2, 4, something like that.
Yeah, but it's mostly technical content. Since it's a blog format, of course we get archived. So posts get archived on a
periodic basis. Yeah.
Yes. So search the blog, because isolation modes described back in the 2008 are still valid. So those posts are still good posts.
And if you want a good Swinglish update, Peter has a great, and I joke, but Peter has an awesome video on isolation modes and how they affect your environment and your application and what they can see and do. It's a great video, it goes through all that in really fine detail.
We have our official community where you can post questions and see other customers getting help. And of course the boot camp. And this is videos, some of them that Dean have created, all in proper English. 15, 20 minutes, one topic. Troubleshooting is there, I think.
Performance enhancement, scripting, application linking, application syncing, a couple other topics as well.
But really good content, and in a very digest format and small format. And if you use Twitter, please follow me and Dean. We use our Twitter accounts not to say hello, good morning, this I had for breakfast. We use it for ThinApp and Horizon-related blasts. So when there is some news or a new blog post, we use the Twitter to announce that. And of course, being the last session this day, I believe, please make sure that you fill out the survey.
And if you have any questions, we have enough time for some questions or some mics. Please step up and to the mic. We want to get those questions recorded, and we'll be happy to answer them. So thank you.
Oh, thank you very much.
Hi.
Hi.
I would like to know, just like in your example, is there a way to reuse some dependent component like Internet Explorer, so to build it and to reuse it in another package without including it in all of them?
Mm-hmm. We have a feature called AppLink, which is bubble-to-bubble communication. By default, 2 virtualized packages cannot communicate with each other. That's not entirely true. Some communication can be made, but they do not see each other. If you activate AppLink, you will tie these virtualized environment together, so they are merged together. So you could have 3 packages app-linking to one and the same Internet Explorer package, for example.
Okay. And another question, when there's a new release of ThinApp that comes out, do you recommend to rebuild all the apps to get optimization?
That's actually a good question, because you don't necessarily have to rebuild unless you need a fix or a feature that's come out. So we always recommend trying to capture with the latest build, because we keep those, all the fixes and everything that are in there. That's where the latest ones are. But if you have an application where a fix or an update is requested or needed, or maybe you want to change out the license, the ThinApp license in the runtime, you can simply use the relink tool that's built right into the ThinApp folder. The relink tool will actually make a backup copy of your original ThinApp package, and then it'll strip out the ThinApp runtime, the old ThinApp runtime, and put the new one in there and just bundle it back up as a new copy. So just make sure when you do that you have enough space for double the number of ThinApp packages, because you can use relink in a wildcard format. So if you do it on a share that has 1,000 ThinApp packages, make sure you have enough room to have double that amount on your folder, on that share, because it will back up everything by default.
And I just want to point out, we have absolutely no conflicts using different runtimes on the same machine running at the same time. So you could have a package created with ThinApp 4.5 running side by side with a package with 4.7.2. No conflicts whatsoever. So you only need to update when you are looking for getting access to new features.
Devin?
Hi. Can I virtualize applications that use ODBC connections?
Absolutely. One of the things that we don't normally virtualize as drivers, because most Windows drivers are run in kernel mode. However, ODBC drivers are run in user mode, so we can virtualize ODBC connections and settings and drivers there. Anybody else? Oh, we have a couple more candidates coming up.
Who makes it first?
Yeah.
Do you recommend if there's settings that are changing, like say like locational settings for like one site versus another, having separate packages for that, or building some ability for it to orient itself for those settings?
If you need to, you can use, you can have separate packages. There's nothing wrong with it. It's whatever's easiest for you. One of our mantras is best practices lie in the eye of the beholder. So if it's easier for you to do that, absolutely. There's nothing wrong with that.
If you didn't want to, what would you do?
If you want to have one single package, one of the things you can do is VB scripting. We do support VB scripting natively within our ThinApp packages. And by natively, I mean it's built right into the ThinApp runtime in this context. So you can apply a VB script which does some validation checking against your environment to see how it needs to configure itself to run the application. And that can happen prior to the ThinApp package, the application within it actually launching. So we've got some government-type customers who use VB scripting to do validation logic, which say, is this hard drive correct? Is the serial number right? Is this Windows system mine? Those kind of things. And if it fails, it could be 12, 15, 20 steps or whatever. And if it fails, what they have it set to do is kick out a little thing that says, self-destruct. So your application will self-destruct in 5 seconds, and it does. So it's a very simple process of doing validation checking. And we've got that blogged on the ThinApp blogs.
And on that topic, another method is to use AppLink. So the funny thing is with ThinApp, most of the cases you have multiple ways of dealing with the problem. So with AppLink, I told you we merged environments together. Then there could happen conflicts. So the conflict rules are last loaded will win. So if the absolute first thing that happens is that your main package is loaded, the environment it's not loaded, but the runtime is made aware of the whole virtualized environment. And then it merges applinks. So if this package contains nothing but a registry key, for example, your new setting, it will actually replace the setting in your main package. So that's yet another method of dealing with customization.
That one sounds funner.
Cool.
In doing packaging over the years, I've found that I am, ignoring now the event log when I see side-by-side errors with the Windows.
Let me have that.
He reminds me all the time.
So yeah, side-by-side, you will always see that. So when you read the events, it says Windows performance and something cannot find this folder. The folder is most of the time the original application folder found in Program Files Directory. Create that folder, empty, the side-by-side issues go away. So my suggestion, if you deploy locally, is to make sure that your ThinApp package is deployed in the original location, not in a folder typically with, well, how do you call these? Brackets? No?
Yes, after using MSI.
brackets.
Brackets. So normally, let's say you have virtualized Mozilla Firefox. The default location when you deploy this ThinApp package, if you wrap MSI around it, would be C program files / Mozilla Firefox brackets VMware ThinApp. Get rid of the brackets VMware ThinApp, and your side-by-side events will go away.
Oh, the parentheses. Okay. Yeah, I see what you're saying.
So in a streaming environment, I would simply
If you're streaming, then either you create empty folders or you have to live with it, unfortunately.
All right, that's a good suggestion. I'll try that.
Yep.
Go.
I'm sure I'm doing something wrong, but I would like to use AppLink to build various requirements, .NET, Java, Flash, Adobe Reader, those types of things. And not have them in my master package when I'm building the app. But quite often, when I'm installing the app, the installation process requires those pieces to exist on the system.
Yep.
So how do I overcome that challenge?
Today, you will have to maintain multiple snapshots of your capturing environment.
Yeah,
Snapshots, virtual machines.
It's a serial process,
Yeah.
so if you need to capture an application which has dependencies, you need to fulfill the dependencies before you start the ThinApp capture process, because the ThinApp capture process uses that good old tried and true Delta snapshot technology. It works, but you need to always keep in mind, what am I pre-scanning and making blind to ThinApp, and what am I post-scanning and then letting ThinApp see in the changes? So yeah.
So my capturing environment contains multiple different operating systems, first of all, and many snapshots of each. So I think my XP capturing environment weighs approximately 150 gig. So I have Office 2003, 7, 2010 installed in different snapshots. IE6, IE7, IE8, .NET Framework, this version, that version, so the whole mess. So that's typically how you're capturing. You should pick your starting point depending on what you are trying to achieve. Because your starting point when you set up capture, will influence the outcome. Mm-hmm. Oh, we are way out of time, right?
Yeah.
So could we bring this discussion outdoors so they could start to clean up the room? Many thanks for coming on the last session.